Hey everyone, it's TJ from Avidyne again. In the following brief video, we're going to be discussing the IFD interface with the NGT9000 and the NGT9000 remote. As always, everything in the following video is for reference use only. For FAA approved data, please refer to the IFD installation manual. Make sure you're looking at the latest revision. So before we jump into the interface, I want to take a quick second to discuss RS-232 versus RS-422. So typically with an RS-232 logic, we're looking at positive 5 volts DC for a logic low and negative 5 volts DC for a logic high. That transition from logic low to logic high doesn't actually happen at 0 volts DC though. It's usually actually around 1.5 volts, meaning anything lower than 1.5 volts is viewed as a logic high to an RS-232 circuit. RS-422, on the other hand, uses two wires. There will be a positive line and a negative line. On the positive line, if we look at it by itself, positive 5 volts DC is a logic high and 0 volts DC is a logic low. On the negative line, however, if we look at that by itself, a positive 5 volts DC is a logic low and a 0 volts DC is a logic high. So theoretically, it's the same logic that RS-232 uses. And because of that, we can actually use an RS-422 transmit negative line to communicate directly with an RS-232 receive input, because the logic is essentially the same because that transition happens at about 1.5 volts. So what we can do is take just the negative line, which sees positive 5 volts as logic 0, same as RS-232, and it sees 0 volts as a logic 1, whereas RS-232 is looking for a negative 5 volts for a logic 1, but again, that transition only happens at about 1.5 volts. So 0 volts is still going to be seen as a logic 1 to an RS-232 circuit. So jumping into the interface, as you can see here, we're using a RS-422 negative to an RS-232 receive. One of the things that you want to pay careful attention to with the NGT9000s is, for whatever reason, L3 has labeled these a little bit differently than what we've traditionally seen in the industry. Usually the A side is the positive side and the B side is the negative. For whatever reason, on the NGT9000s, they have those labeled in the reverse. So the A is the negative and the B is the positive. Got to pay careful attention to this and make sure that we're not just going by the A and the B, but we're actually keeping track of the positive and the negative, because the negative line is the one that's carrying the data that can be translated into RS-232. If we use the positive line, it's going to be reverse logic and you're going to have all kinds of problems. On the IFD side, we're going to set that receive port. Well, actually, we've got a lot of options there. We can set it for capstone traffic and weather. We can set it for capstone traffic, or we can set it for just capstone weather. If we're using the straight capstone protocol, it's going to be a 38400 baud rate, or we can do capstone high-speed versions of all three of these, either traffic and weather, or just weather, and we're going to set that for a 115-200 baud rate if we're going to do the high speed. If we're talking about the NGT9000 remote, we're actually going to add another pair of RS-232 lines, RS-232 in and out. And on the IFD, we're going to set the in and the out port on that for NGT9000R. We're also going to add a pseudo weight on wheels connection for any aircraft that doesn't have a traditional squat switch or a way to transition that. And you notice we're still using the RS422 connection out of the NGT9000 to an RS232 input on the IFD. In either version of the NGT, whether you're doing the panel mount or the remote mount, the NGT does require its own altitude source. That will not be provided by the IFD. It needs to have its own dedicated altitude source. And it should also be noted that the NGT has its own GPS antenna connection. The IFD is not providing GPS data to the NGT either, whether that's panel mount or remote mount. Their installation documentation calls out the use of a splitter, which can be used to share that GPS antenna with an IFD, and that's fine. There's no rules broken there. That should work just fine. The key to understanding how this splitter works is understanding that a WAAS antenna is a powered antenna, and usually it's your GPS receiver that's powering that antenna. If we're going to split it, we can't have it powered from both sources. So what the end result of that is the splitter is going to block one side from powering the antenna and making it just a passive receiver. And it's going to pass through on the other side for one of these GPS receivers to power the antenna while both are passively listening. So whichever receiver is connected to the DC through on this splitter is going to, that's going to be the one that's actually powering the antenna. And then the other receiver is going to be on the DC blocked side. So it's just going to be a passive listener on that GPS. Big thing to keep in mind here is this is really, really useful in troubleshooting. If for some reason we've got some GPS issues and we suspect that the receiver's not powering the antenna correctly, if you know where the splitter is at, you can actually swap the coaxes to have the antenna powered from the other GPS and help narrow down the problem. Okay, so something to keep in mind. Real useful for troubleshooting to kind of understand how this works. And that's it for this interface. As always, if you guys have any questions or comments, feel free to share those to techsupport@avidyne.com. As always, thanks for watching, and we'll see you in the next one.